encounter spawns that move around and follow the player and try to attack him on the overworld. But this time, we're going to actually set up the player so that you can actually move around on the overworld yourself, right? We'll need to make sure that everything works properly, and so let's get cracking on that. So I'm going to do this a little bit differently here today because I had a little bit of technical difficulty. So everything's already in place. So I'm just going to kind of open it up and just talk to you about it from that point. So let's check over here. So to start off, we're going to be spawning mobs. And so you'll see this also in the idle state and the move state. But so when I put together the overworld encounter objects, I kind of used the traditional move grid like this, where you have the 1, 0, 0, -1, -1, 0, 0, 1 to tell your player which grid position to move into. But in the case of Link's overworld object, I tried to make it a little bit different in order to just, well, have something different. I wanted to try doing it a little bit differently. But so there's a lot of stuff in here. It's not necessarily better or worse, but it's different. So I don't know. Choose your favorite way, whichever one makes more sense to you of how to do this movement stuff. So, anyways, what we're going to do here is spawn our mobs. There's an encounter timer, which I've already talked to you about, and we put it down over here in our timers. And there is a step counter, which is how many grid steps you've moved, how many grid spaces you've moved. And we also do check to make sure that there are no spawns currently existing. So if the encounter timer has reached 0, or your step counter is greater than or equal to 16, so if you've walked more than 16 steps, and this step counter is kind of false in that you should actually, instead of using 16, you should be using a variable determined by the current tile type that the player is standing on. But I didn't put that into the player character, but that's how it worked. And I'll get a little more into the current tile situation stuff when we actually talk about the moving system. So, anyways, after you have moved 16 tiles or the encounter timer has reached 0, we're going to spawn a mob, or actually we're going to spawn 3 encounter mobs onto the world. And the mobs can spawn either to the right, left, above, or below the player with 2 tiles of spacing between them and the player. So we have this list here of spawn positions, which determines ds_list_add _spawn list x cell. So the player's current x cell times tile size, and this converts their x cell position into a pixel position, plus tile size times 4. So that's actually putting the this will be putting the mob. This is a spawn position that is 4 tiles to the right of the player and at their Y position. So not 2 tiles, it's 4 tiles away from the player. Then we have X cell times tile size. So at their X position, but at Y cell minus the tile size. So that puts it above the player. And then this one is to the left of the player, and this one is below the player. And then I use ds-list shuffle to randomize the positions of these things, because what we're going to do is we're going to pull the first 3 options in the list and use those to spawn our encounters. And here I set up this inline function, or method, as you would call it, I guess. And you don't necessarily have to do it this way. I just did it because I thought it was, and interesting way to go about doing it. I think I had a reason at the time, but I can't really remember why. That seems to have become obsolete, but the code is still there. Basically, I'm just I'm just setting up the encounter timer reset. So once you call this, it'll reset the timer. We have this switch based on our current tile type. So this is something I didn't really implement into the game. But you remember the overworld, you have your tile types and everything, right? But we have these solid tiles, but we could actually, it would have well, I only have the collision tile set. I didn't make a tile set for actual tile types, but if I were to do it, I'd make another system exactly like this, except it'd just be a whole bunch of squares where this was like labeled square one and then 2, 3, 4, 5, 6, etc., etc. Then you'd have, okay, well, these are our grass tiles, and these are our road tiles, and you would you use something else as your road tiles, and so on and so forth, right? Let's delete that. And then based on where you land at the end of your movement system, it updates your current tile by doing a test of what the tile type is at that current position. And that updates your current tile type. So based on what your tile type would be, so like if you're on a path tile, then you would just not spawn anything at all. And you would reset the timer. Notably, you should note that you don't reset the step count. So if you're on the path, you would actually just let the step counter keep going until you actually step off the path, in which case, if you've been on the path long enough, you'll basically instantly spawn a enemy at that point. But yeah, that'd be how it works. And then we destroy the spawn list because we don't want to have it lying around. That's a bad idea, as usual. And then if the step counter is greater than or equal to 16, step is equal to 0. This should be in here, probably. So we have the current tile type. If we had the, if we were on a path, then we wouldn't include a step reset. But if we are on a path, if we aren't on a path, then we would include the step reset. Anyways, so that's how you spawn mobs. Oh yeah, just going over it. We spawn based on the spawn location at the 0 and 1, which are X and Y positions. And we use this repeat loop. The reason why I use repeat rather than a for loop is because repeats are technically faster than a for loop. So I did it just as a minor performance thing. You don't actually have to do it this way if you don't feel comfortable with doing it that way. It's only really matters if you're in a very high performance sort of game like a Forger or something where you have hundreds of entities in the room at the same time, where every bit of performance you can eke out at that point matters. But yeah. So make sure you make the overworld encounter at the enemy's lair. Coming back to our player here, we need to remember to have a draw event because, well, that's what we're doing. The reason why we're doing this is instead of just drawing our player is because if you remember correctly, we are using we are going to be using the X scale to flip the player back and forth for when they move left or right. Technically, I should have just duplicated the sprite and made a separate left and right sprite. That would be the easiest and the most modern way to do it. But, you know, I'm trying to kind of emulate the original system at this point, and I thought, okay, well, how would they have done it? How would they X scale flip their sprite without actually without having it change the position? Because remember, the sprite is top left origined. So that makes it a bit problematic when we're trying to flip it left and right because, well, if we're trying to flip, if we're going to do an X scale flip, then that means we X scale flip, and now our character is drawn 16 pixels to the left of where we want him to draw normally. So if we come back to Link here, the way we fix this is by having this little offset where we basically tell, okay, if our X scale is currently 1, then -1 plus 1 is 0, sine of 0 is 0, so we don't have an offset. But if our sine is -1, so if we're currently flipped to the left, then we get -2. The sine of -2 is -1. -1 times the tile size would give us a 16 pixel offset, and we therefore we move 16 pixels, where we draw ourselves 16 pixels to the left of where we think we're at. Right? And of course, remember to have our X scale there as our X position. And yeah, just a little debug stuff here if you feel like it. Just drawing your hitbox. Same thing in the draw GUI. It's just debugging stuff I have in there. It's not really important unless you really unless you want to figure out a little bit about how to do your own debugging and stuff. So let's come back to our player's movement system here at this point. For those of you skipping ahead, right? So we have two different states for the player. He's going to either be idle or moving. Let's start with the moving because it's very simple. We have the collisions and movement, where we basically, if you remember correctly, we copy the code from here, basically, from our overworld encounters. We have a minimum of 1 or frames in state divided by animation length. So we divide the amount of frames that we want to be in the movement state. So I believe we defined frames in state back over here. So that's how many frames we've been in the state currently. And then we have our animation length, which is we want to last for 0.3 seconds. So if we've been in the state for 0 frames, aka we've just gotten into the movement state, it'll be 0 divided by 0.3, which is a value of 0. So the minimum of 1 and 0 is 0. And we come down here to our animation. We say, okay, well, our image index should be the array length of index, this guy. So 1, 2, minus 1, so value of 1, times time. Time is 0, so that would give us a value of 0. And we round down to 0 at that point. And that gets us everything we need to animate our player properly. If we were to then say we've been in the state for 0.3 seconds, that would give us a value of 1. And if we come back in here, we have array in length of index is 2 minus 1 gives us 1. 1 times 1 is 1. Round to 1. Image index should be equal to 1. So, and our frames in state plus, as usual. Then we also have our X and Y position. We move our X and Y position based off of the current position that we are from to the position that we are going to based on our time times tile size. So we're lerping from our current X position to our Y position by time. And we're not like actually adding. So because the way we're doing this, we're always calculating the from position to the to position. So therefore we can then use our time, and let's say we're at 0. So we do our little calculation, we come out at 0.5, right? So we'd say our x from to our x2 by 0.5, and that would give us 50% of the distance from the x from to the x2 position. And part of the reason why we use lerp is instead of just like multiplying or something, is because apparently there's something in lerp that makes lerp execute faster than normal math, but again, it's kind of advanced using lerp here. But you could just do it kind of yourself. Just x from x2 minus x from times the 0 point times time. That would give you the same value basically. I think it's because in this case you only do one execution of a calculation rather than three, where you have to add then multiply. And in this case, you're just doing a single calculation of the from to the to as a percent. That's why it's a faster or something like that. Okay, so that's the collision and movement state. We also have the idle state. We need to be able to return to the idle state. That's probably very important, right? So we calculate time here. And yeah, I'm doing it twice for clarity, as I say here. And I did it once up here in the idle state, but I do it again just to make sure that the person actually knows that this is actually happening down there. You don't have to bother if you don't feel like it. So if our time has reached 1, so if we are at the end of our time in this state, then change my state back to idle, set my x from, my y from to my current x cell and y cell, my x2, my y2, the current y cell and x cell as well, and step count plus plus. So our step counter for our spawning, we plus plus that at the end of our movement. We also have this landmark check. I'll get to that in a second, but just remember to execute your new state and exit from this state so you don't get caught in an infinite loop. So with our landmark check, we basically, as we set up previously, we have landmarks which tell our player where to move to based on what they are. So in this case, this is Room North Palace. And there's no audio change because the audio doesn't change between the Overworld and the North Palace. And the entry direction is right because we're supposed to enter from the right. And if we come over here, so basically what we're doing is we're checking for a object over the landmark transition, and if there is a transition at the point in our X and Y cell that we're currently at, then we have a landmark transition to it. The current save data, the entry direction is equal to instance.entry direction. So update our entry direction. If instance underscore global audio change is not equal to no one, then cue a new song. And then fancy transition using a fast fade from our current room to the room that we're supposed to be going to. And exit. Simply exit instead of triggering the normal idle state material. So typically you would normally go back, you would execute your idle state, right? But in this case, we have found ourselves in a landmark, so we actually just want to continue to be in this move state. We'll always be finding ourselves as since we continue in the move state, we'll always be at more than 1 on the time, and it will just run this calculation. Then it'll hit here, it'll find, oh, there's a transition, I should probably update all this information, then fancy transition to the room and exit. Fancy transition takes into account that if there's already a transition, then it doesn't do anything, so that's good. So we just be simply exiting. Though I don't want this stuff to all be executing though, because we've already done it once, so no need to bother. So what I would actually do here is the same thing that's going on right here. And say, well, there's already a function for this too that I already created. So if transition finished, so if not transition finished, then exit. And transition finished is, like I said, All right, we should be good to go on that bit. So that's the movement system. But we haven't even talked about the idle system yet, which is the reason why we haven't talked about the idle system yet is because that's where a lot of the calculations and everything come in. So in the idle system, there's no accelerations, no speed fractions, no collisions. Just update our frames in state and check for moving to our move state. So we have these variables X and Y motion. This is where I try to get fancy and try to come up with my own new system. I don't know if it's actually any good or not, but you can do what you want, or you can just use the system that's in the overworld encounter objects, which is basically exactly the same thing, except in not the same words. I was just trying to come up with my own words for doing it. So we have our X motion and our Y motion. If X input or Y input do not equal 0, then we want to find out which direction the player is trying to input our attack for, and set up our facing direction to be the rounded of the input direction divided by 90. So for 4 directions, if the facing direction is equal to 4, set it back to 0, because even though technically when you do angle calculations, if you get 360, it's supposed to automatically transition that back to 0. For some reason it doesn't. Sometimes it just randomly chooses to not do so. So you put this in here anyways. Then motion, based on what direction you are currently facing. So if the player has pressed 1, which would be right, then you get a value of 0, and 0 is therefore right. Then my X motion should be equal to 1. And a break. And base, if X input does not equal 0, X scale is equal to X input. So that'll flip the X scale of the image based on what your X input is. So if we do this, what we are going to do is we are going to prefer X motion over Y motion. So if X input does not equal 0 and tile map does not equal collision, so if we aren't finding a collision at the position that we're trying to move into based on our XL plus X motion, and our X input does not equal 0, then change state to the move state, X2 plus equal X motion, XL equals X2, and so basically we say the position that we want to move to is the X grid position that we want to move to plus equal X motion to find that. Then our X cell is equal to X2. And we then next do an update of our overworld X cell, our current X cell. We set that to the X cell. And our facing direction, again, for some reason I have it set up twice here. I don't know why I'm setting it twice. It seems kind of weird. But apparently I do that for some reason. Then we do event user state and exit. Same thing for the Y. Check to make sure we don't have a collision tile in our Y system movement. Then we go to our move state, add to our Y motion, and change our Y cell position. And again, update our facing direction based on what direction our input was. Which I did right here. I don't know why I do it again, but apparently I did it again for some reason. So anyways, then we execute our state. So that's everything we need to do to get Link moving. So let's test him out. Come back here. And we're in our room. And we are in the overworld, so let's press right. As we can see, we move. And we even spawn some enemies. You'll note there's a little jig there in the camera. That would be because there's a slight pixel problem of being one off somewhere. And also the overworld enemies don't seem to come all the way to Link. They stop about 2 grid spaces away from him for some reason. I have no idea why. I'd have to actually do some debugging on this to figure out why. But as we can see, we can't move into those positions. Wish I knew why we were having this plus or minus 1 pixel jog. I don't like that. Anyways. Oh, that was a bit noisy. That would be because if we come over here to our step event and we say instance create layer, encounter check. So I say if instance is equal to instance place of the overworld. If instance does not equal no one, then it's in my battle room, go to that room, and so on and so forth. And it's same thing again. And come back over here to our event. And we say, where did I put that? Oh. That was over here. Let's come back to our step event, stick that in there. If we're currently in a transition, then don't do anything. Yeah, that should be good. All right, so that'll stop the world from putting all this music. And no, we got some friends already, so it looks like they did some damage to me. And oh, I forgot. Don't kill the red ones unless I want to be leveling up a whole bunch. But one of the things I did notice is for some reason the moblins aren't spawning, so I got to figure out why that's happening too. So you'll note a bunch of little bugs here that are just from my transitioning of code from my main project over to here. So I'm going to have to do a bit of debugging at some point in order to find all the errors that are being caused. So I'm probably going to actually do that as a live event, and if you want to get a little bit better at debugging, then you should probably join in the premiere whenever I actually do that. So keep an eye out for the live debugging event one of these weekends. So thank you everybody for joining me. I'm going to let past me take it away with some Patreon names at this time. So I'd like to thank my legacy Patreon sponsors who supported me last season during the hiatus. Jens Burton, JD Lowe, Suli, and Vazia. I of course also like to extend my thanks to my current Patreon sponsors. Kenneth Klein, Confusion, Jamal, Fernando, Sergez, and lastly, Amy. Thank you everybody for supporting the NESGameMaker. You really help it all happen. And remember, good luck with your program.